Hello everybody, my name is Marco and I run Polaris Studios, and today I'm going to be showing you how to make Pong using Python and Pygame. So in this section we're just going to go over general setup. So first things first, if you do not have Python, in the description I will have a link to download Python. Once you download that, you can run pip install Pygame and that'll give you the Pygame module. Perfect, everything's ready to go. So we're going to do two methods in this section. One is called an integrated main method, and the other version is a game class method. The integrated main method is one file, one area of responsibilities. Now, I have nothing against this method. It's cluttered and it is harder to read, but in terms of organization for a small project, that might be more ideal because it does contain everything that you need within this encapsulation one file. The game class method, you are going to have a much smaller main method and you're going to have a class that runs everything. You can isolate everything into their own functions, making it a bit easier to follow. And we also have a third method. In the description, I'm going to link down to Polaris Kit. That is a game engine / toolkit that I developed. That, in my opinion, is a very strong way to make 2D games. But for the purposes of this tutorial, because Polaris Kit is a paid toolkit, I'm not going to be going over it in this series. I will, however, provide in the description a link to where Polaris Kit and Pong are covered. So for every single file that is going to be using Pygame, we're going to want to import it. That just gives us access to all of the modules within Pygame. We can run a very simple pygame.init. So this initializes Pygame. This is what actually allows us to start using it. Every single game needs a screen. We're going to initialize that using pygame.display.setMode. And in this tuple, we're going to go 1280 by 720. That will define the constraints of our window. We're going to use a clock, and that will be for us to determine the frame rate. So if I was to try and run this as is right now, I'm going to get the frame popping up for about one frame and it'll close. That's because we read code from the top to the bottom. We're initializing, we're setting a screen, and we're setting a clock, and we're terminating the program. So we need to find a way to keep this window open for as long as we want. That's where this running equals true flag comes in handy. This is basically going to say, while I determine this running flag to be true, we're going to do code. What do I mean by this? So while we are running, we're going to continuously update our screen with all of the game logic. So updating the ball movement, updating the paddle movement, calculating the score. All of these things will happen while the game state is set to running. So first things first is we need a way to close the screen once we're done with it. That's where for event in pygame.event.get comes into handy. This will give us a list of all the events. So quitting, key down, key up, all these type of events. That's where we can type if event.type equals pygame.quit. We can then set running to false. So let's open up this screen. We can see one more time. Screen opens up. If I hit X, screen is closed because running is now false. Everything looks fantastic so far. Next thing I'm going to do is outside of this while running loop, we're just going to add pygame.quit. This will just be a cleaner way to quit Pygame once we're done with it. I also want to add this pygame.display.flip method and this clock.tick method. What this does is we're telling Pygame run at 60 FPS, and this .flip method, it'll just update our screen every single frame with what we want to see. So we already have a pretty good flow going. I'm happy with this. The next thing I want to quickly cover is game state. What do I mean by game state? Well, if I'm at the title screen of my game, or if I'm at the hub or the file select, how does my game actually know that? For the main integrated method, it's as simple as game state equals main menu. Main menu. So I'm basically initializing it as main menu. How do we know we're on the main menu? Well, we can write if game state equals main menu. Let me just tidy that up a bit. We're going to fill the screen with a tuple, and that will be a 40, 40, 40 RGB value. So this is the color of the screen. I have told it if our game state is main menu, give me a gray colored screen, which is exactly what it does, which is fantastic. If we were to change this to, let's say, hub and run it, we get a black screen. So this is already looking great. Next thing that we want to do to end off this main integrated method is a button press to switch our states. So if you remember, just like how we determined how to quit the game, so if Pygame event type is key down, and if event.key equals Pygame.k underscore1, k underscore 1, we're going to set our game state to equal hub. And then if we press 2, we're going to set our game state to main menu. So now we can copy this stuff over and we can do an elif statement here. And if it's the hub, I want to paint it blue. So what have we done so far? We can now quit. When we press 1, we switch to the hub. And when we press 2, we switch to the main menu. So when I launch up my screen, we can see that we do have one mistake. I did accidentally do equals equals here, so that was why it wasn't running. But we start off with the blue in the hub, and when I press 2, we switch to the main menu, which is why it's gray. So once again, 1 and 2 to switch our states. Everything is looking really good. Now we want some text. We want to say, where are we actually? We can do that by rendering text using font. So I'm going to initialize font using pygame.font.font. I'm going to say none to default it, and I'm going to say it's 74 pixels. So this is the size of our font, and this is the font type. If we had custom fonts, we would initialize it here, but for the sake of this example, we're just going to set it to none. So let's render our text. We can do main equals formatted string main if game state equals main menu else hub, and then we can do our main text equals font dot render. And now the way that this works, if you can see, we take a text, which is a string, we take an anti-alias, which is a true or false, and we take a color. So we're going to say we want the main text, we want anti-aliasing enabled, and our tuple will be white text. Then the next thing that we need is a rectangle to actually place on the screen. So a rectangle, you can kind of think of that as the hitbox, for lack of a better term. It's the hitbox of the text. We need to know where to position it. So we can do main text rect equals main text dot get underscore rect center. You can use center, you can use mid left, you can use bottom left, you can use bottom right. And then I'm going to tell it that I want it in the center of the screen. So 1280 divided by 2 and 720 divided by 2. Then finally, we have to blit it onto the screen. So screen.blit main text and main text rect. So let's run this code, and now you can see we have the hub, we have main. So we have dynamic text working, and we have the background working. So this already looks pretty good to me. The next thing that we're going to try and do is we're going to look at this game class method. So in Python, you have classes, and we can use these classes to clean up how our main looks. So I'm going to bring this back, and we're going to just copy paste everything. So what do we actually need from here? Well, we can get rid of our state stuff. We can actually get rid of all of our events here. We can get rid of all of our text. We can get rid of all the game state. We can get rid of pretty much everything in here. And this already looks cleaner, more maintainable, and we don't really need much more from this. Next, we're going to go into our game class. So this is going to be where mostly everything is handled. So we are going to import Pygame, and then we're going to create a class game. And then we're going to define an init method. And all this is basically an initialization method. So you could do this, game state equals, and I will use main. You could do this, but that's not the point of a class. You can see that in the init there's self, which is basically just a reference to the class that we're making. So we're going to do self.gamestate. We're also going to do self.font. And this will equal to pygame.font.font. We're going to do our none74 again. And everything looks great. So within this game class, we're going to need a couple functions. We're going to need a run, which takes self, it takes events, and it takes in our screen. We're going to just pass for now. We're going to need a update, which takes self and events. And we're going to pass that for now. And we're going to need a draw, which again takes self and screen, and we're going to pass. So now we have 3 methods and we have our init. How do we use this? So in the game class, we're going to do from game class start import game, and then we can actually just use it here. Game equals game. So we have now created an instance of our game class that we can access everything that we have defined here. So we have access to the game state and the font. Great. So from here, all we have to do is right before we update the flip, all we have to do is call game.run, and we pass in the events and the screen. So events and screen. And because we do need this events thing now, what we can do is we go events equals pygame dot event dot get, and then this can be changed to for event in events. So now we're passing in the list of Pygame events, so our key down, our key ups, and we're also going to be passing in this 1280 by 720 screen into our game.run. So in our game.run, what do we need to do? Well, we just need to run the update with events and our self.draw with the screen. So now we're telling that when we are running, while this running loop is true, we're going to call this run, passing in a list of events and our screen. From there, we're going to be updating it with events, and we're going to be drawing onto the screen the entire time. So as you can see, it's already getting a little bit more manageable and easier to read. So we can just do pretty much the same thing that we had in the previous version. If event dot type equals pygame dot key down, if event dot key equals pygame dot k underscore 1, self dot game state equals main. I'm going to bring this down. If you press 2, we're going to say this is now our game state. So we have a way to manage what state we are currently in, already looking much better. And then in our draw, this is actually how we're going to be drawing onto the screen. So if self.gamestate equals main, we're going to do screen.fill, and we're going to give it a tuple of, let's say, more green than anything. So 0, 70, 0. If the game state is game, I want to go for more like turquoise color, and already things should be looking much better. So let's do py main game class start, and you can see I did draw screen. So I did not mean to write little brackets there. So I just had it look like it was invoking a function. That's not what I meant to do. Now we should be much better. We can see that we can now toggle between our states. So once again, looking great. Same thing for the text. If you want to render the text, not a problem. We can do the same thing. Main equals main. If self.gamestate equals main, else game, then main. text equals self dot font dot render. Then we want our main text. We want anti-aliasing true, and we want it in white. Our main text rect equals our main text dot get rect. Center equals 1280 by 720, and we want to divide those by 2. And then finally we want to screen dot split. Then we would pass in the main text, and we would also pass in this main text rect. So when we run our code, we can see main game. Everything is looking pretty much the exact same it was before. So we have done an integrated method and we've done a game class method. If you take a look, this main is a lot cleaner, a lot easier to understand. Overall, this looks good to me. If we take a look at our game class, it could be refined, but it is a great start. Now, when I say it could be refined, here's something that, for example, here's what I would do. What happens if we have multiple events? So if event.type equals Pygame dot, let's say, key up. And then we have to run a bunch of code. What happens if we have if event.type equals Pygame dot, let's just even say mouse button down? This will get very unmanageable very fast. So a method to fix that would be to create a handler. Self.handle key down and pass in the actual event that happened. Then we would just define handle key down with self and event as the argument. We are going to get rid of this block of code here, and we're going to indent this. And now we have the exact same stuff, but now we have a separate handler for whenever the key is pressed down. We would have a separate handler for when the key is pressed up, or when we click the mouse, for example. So just a little bit more refinements. And I would also honestly do the same here. So self.draw background and pass in the screen, define draw background with self and the screen. Take all this and indent it, take all that and do this. So now we have one handler for this, just handling our background. Then I would also do a define draw main text self screen. And now we have a way to handle the main text, and we have a way to handle the background, which in my opinion, cleaner, easier to read, easier to manage. So if we were to run this, everything is the exact same, no problems here. So we have covered the screen, how to do some text, and the actual attributes of the screen itself. So in the next part, we are going to aim to cover the ball and the ball physics. So collisions, bouncing off the wall, and how to make sure that the ball never goes off the screen. So yeah, I will see you guys in that video.